Alright everybody, welcome to 2.3. We are simplifying variable expressions. Okay, so what does that mean? Well, first of all, we're talking about variable expressions. We're going to have variables, a, x, y, so on and so forth, and expressions, which means I'm going to have numerical sentences, but they're not going to have equal signs. Okay, so for example, let's look at this. If I had 6x plus 3x plus 7. We would call that an expression, right? I have numbers, I have some variables, and there's no equal sign, so it's an expression. So what do I have here, though? That's the question. Well, first of all, I have things that are called terms. Okay. Well, what's a term? Well, it's a part of an expression that's added or subtracted together. Okay, so terms. Parts of expressions. So there you go. The parts of expressions that are added or subtracted. So in this case, what are the terms? Well, in an expression, everything is actually a term. So 6x is a term, 3x is a term, and 7 is a term. They're all terms. Okay. So what else do I have, though? Well, I have some other things that are called constant terms. What's a constant term? Constant term is really a number. Okay. So what number exists up there? Well, there is a 6 there, there is a 3 there, but it's a 7. There's a 7. And he's different than these two. And why is that? Well, he's standing alone by himself. He's not being multiplied, okay, by anything such as a variable. Like the 6 is a number, but he's being multiplied by x. We know that 6x actually means 6 times x. The 7, he's just by himself. So 7 is our only constant term. What else do we have? Well, we have things that are called coefficients. What's a coefficient? Well, it's a number that is multiplied, multiplied, multiplied by a variable. Okay, so what are my coefficients here? Well, I have a 6x, but what's the coefficient? Well, it's only the 6. Okay, 6 is the coefficient of the term 6x. Now I have another term with a variable in it. That term is called 3x. But what's the coefficient of that term? It's a 3. Okay. And so lastly, I have what are called, I just have to kind of make it small for a sec, like terms. Okay, what are like terms? They are terms that have identical variable parts or no variable at all. Now, one of the rules with like terms is that you must have at least 2 common terms for them to be like terms. Okay, so let's go back up here. We're going to circle the like terms. Okay, well, this is a term, that's a term, and that's a term. Now again, like terms either have identical variable parts or they don't have any variables at all, but you have to have at least 2. So here's a term that has an x. Here's another term that has an x. So what are my like terms? 6x and 3x are my like terms. Now the 7, what about him? Does he have a like term? Otherwise known as, is there another number out there that exists that does not have an x next to it? Not in this expression. So he is a constant term, but he doesn't have a like term, or he isn't a like term to anybody else. Alright, so your next task is to pause the video, and I want you to identify the terms, like terms, constants, and coefficients of negative 3a plus 7 plus 9a minus 11. So go ahead and pause the video, fill out your paper there, kind of like I have it here. Go ahead and see if you can identify those things, put them in the right categories, play the video when you're done, and we'll see if you got it correct. Alright, so what are the terms? Well, the terms would be everything that's present there. I have a negative 3a. I have a 7. There's a 9a. There's also a negative 11. So all those things are terms. Now what about like terms though? Well, I have negative 3a and I have a 9a. Those are like terms to each other because they both share the variable a. Now I also have a 7 and, or I'll just keep for consistency's sake, just use my little and sign, negative 11. Now it's important to keep in mind, 7 is not a like term to negative 3a. And negative 11 is not a like term to negative 3a or to 9a because they don't share, one of them has a variable and one of them does not. Constants, do I have any constants? Well, yeah. 7 is a constant because he's a number without a variable. I also have negative 11 as a constant. And what are my coefficients, the last one? Well, remember coefficients are the numbers that are multiplied by variables. So I have a negative 3, which comes from right there. I also have a 9, which comes from right there. And you're done. Hopefully you did it correctly. If you didn't, that's okay. Just go back, kind of look what I did, make sure you understand, and then we'll move on. Alright, so now we're going to talk about simplifying expressions. Okay, so simplifying expressions is really easy now that we've learned about constant terms, or like terms really, is the big one. It's going to help us simplify expressions. To simplify expressions, we simply combine like terms. So if I have any like terms, we can combine them. So we have the expression 4y minus 2 plus 23y plus 47. So what are my like terms? Well, as far as the variables are concerned, I have a 4y, and I have and it's a positive 4y, and I have a positive 23y. And if I combine 4 and 23, I get 27. But we're talking about 4 y's and 23 y's. So it's like I have 4 yo-yos, I add to it 23 yo-yos, now I have 27 yo-yos. Now, what about the numbers though? Well, I have negative 2 and I have a positive 47. So commutative property of addition says I can actually make that 47 plus negative 2, okay, which is the same as saying 47 minus 2, which of course is 45. Oh, I shouldn't really circle that, I'm not done. 45. Yeah, I can't erase that for some reason. Ignore the circle. Okay, so what does that mean in the end? Well, it means my expression is a positive 27y, and then I have a positive 45, or plus 45. And there you go. So why don't you try this one? Take a minute, simplify that variable expression by combining like terms, and let's see what you get. Alright, so hopefully you knew that negative 3b and then negative 6b were like terms. Okay. Well, negative 3b minus 6b, well, negative 3 minus 6 is negative 9, but we're talking about b's, we're subtracting b's here. And then we also have a 7, and then we have a plus and negative 3. Well, remember, plus negative 3 just means plus a negative is the same as saying subtract, so 7 minus 3 is 4. So hopefully your final answer was negative 9b plus 4. Now, would it be wrong to write it as 4 minus 9b? No, it wouldn't be wrong, but we really prefer to write it in exponential order as well as with the variables first, so I prefer this. Alright, so what if we were to simplify this variable expression? Well, you'd think, oh, okay, combine like terms. Yes, you would be correct. However, there's a catch, or a little something different about this one. If you notice, we have a set of parentheses here. We also have an exponent here. So what we need to do is we need to just take a second and say, okay, order of operations says I do what first? Parentheses, okay? Or grouping symbols. Now, the question is, can I do it inside the parentheses, x minus 4? No, I can't, because I can't take x and minus 4 from it, or subtract 4. They're not like terms. So I have to leave it and move to the next thing. Exponents, okay? Well, exponents, 1 times 1 squared is, or 1 squared is just 1 times 1, which is just 1. So I'm just going to rewrite it 2 times x minus 4 plus 9x plus 1. Okay, now let's move on to multiplication or division, whichever one comes first. So, oh, I don't see any multiplication, right? Wrong. There is multiplication. Where's it at? Anytime you have a number next to a parentheses, that means multiplication. So here's where we use the what property? Distributive property. And I use that by taking 2 times x, which gets me 2x, and then 2 times negative 4, which is negative 8. And then I just bring down everything else that I haven't touched. I have this positive 9x and plus a 1. So now that I've gotten everything out of the parentheses, I like to treat parentheses kind of like prisons. A lot of times we want to break them out of prison. Okay, we've done that. Now I can combine like terms. So what are my like terms? I have a 2x and a positive 9x. So that gets me a positive 11x. And then I have a negative 8 and a 1. Negative 8 plus 1 is going to get me negative 7. And 11x minus 7 would be your final answer. Alright, so the last one we're going to do has to deal with exercise, okay? So let's say you go to the local rec center, right? And you're going to spend a total of 45 minutes. We'll just say at the YMCA, okay? 45 minutes. Okay? And you are going to jog and you're going to swim, okay? And you burn 14 calories per minute jogging. And you burn, let's see, we'll do 18. Yeah, no, it's going to be less than that probably. Yeah, 8 calories per minute swimming. Okay. And so what we're going to do is we're going to set up an expression in terms of the time you're jogging. Okay. In terms of the time that you are jogging. So what does that mean? Well, let's think about what we're setting up here, okay? We have a total of 45 minutes that we're spending at the gym. What are we doing with those times? Well, I'm jogging and I'm swimming. I'm combining the time of both. So when I jog, I'm going to burn 14 calories per minute. But how long am I jogging for? Well, at this point, we haven't actually said how long you're jogging for. So I'm actually going to do 14 times j, which we can simplify to just be 14j. Now we're going to add to that, so this is kind of setting this up to figure out how many calories we're burning. The calories you burn per minute swimming. Well, I burn 8 calories per minute swimming. But how long am I swimming for? Well, again, we don't know. But we do know something. Okay? I know that I'm spending 45 minutes at the gym. And I'm going to do some jogging and some swimming. So, the amount of time I swim is actually going to be 45 minutes, which is the total time, minus the time you jog. Now, that might be a little confusing, but let's just think about this. If I jog for 40 minutes, I only have 5 minutes to swim. That would be like saying 45 minus 40, which is 5, right? Okay, so how can I set up this expression a little bit better or more simply? Well, now I can use the distributive property. Okay, and there's really a plus in between these right there. So 8 times 45 is going to get you what? Well, 8 times 45 would be 360. Then I have 8 times negative j. 8 times negative j. That's interesting. What does that mean? 8 times negative j. Well, keep in mind, negative j is like saying negative 1j, and 8 times negative 1 is negative 8, and I don't have anything to multiply the j by, so I just leave them there. So I have minus 8j. This right here came from that right there. Now, what can I do with this thing? Well, I can actually simplify it because I have like terms. 14j and negative 8j. Well, 14 minus 8 is going to be 6. Talking about j, though, time jogged. Plus Well, 360. And is there anything else that I can do here to simplify this? No. So that is actually the expression that would help us. And what is it helping us do here? It's helping us figure out how many calories we're burning at the gym. Alright, that's all I have for you in this video. Again, this was 2.3, simplifying variable expressions, and I will see you in class.